Okay students, good morning. In the last class we have studied the distance between the any 2 points where the given points are three-dimensional geometrical points. So we have solved some of the problems also. So in this session, in this class, we will continue the solving problems. Look at this problem. Given that, show that the points -2, 3, 5, 1, 2, 3 and 4, 9, -6 are collinear. Okay, we know the definition of collinearity of the points. Two or more than 2 points are said to be collinear if they lies on the same line, in general. But in case of the using the distance formula, how to show that they are collinear? That is simple, that if the point P, distance between the point P and point Q and point Q and point R such that PQ, the distance PQ plus the distance QR, if it gives rise to the distance PR, then we can say that P, Q and R are on the same line, they are collinear. So in this case also, let us solve the same one. So what is given? Solution, what is given? Given is the point P -2, 3, 5, Q 1, 2, 3 and the R point 4, 9, -6. So let us find the distance PQ. We know that the distance between any 2 points is the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So by taking the P and Q points, coordinates of the P and Q, let us substitute the values. 1 minus of -2 whole square, 2 minus 3 whole square and 3 minus 5 whole square. So what is the value for this? So 1 minus of -2 is +2, 1 plus 2 whole square is 3 square, 3 square is 9, plus 2 minus 3 is -1, -1 whole square is +1, 3 minus 5 is -2, -2 whole square is +4. So 9 plus 1 is 10, 10 plus 1 is 10 plus 4 is 14. We got the distance PQ. Similarly, let's go for the distance, the QR. Let's go the distance QR. Use the same formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So use the coordinates of the point Q and R, substitute here. Take this as x1 y1 z1, take this as x2 y2 z2, substitute here. So we get 4 minus 1 whole square, 4 minus 1 whole square, 9 minus 2 whole square, and last one is -6 minus 3 whole square, -6 minus 3 whole square. Let's solve this. So 4 minus 1 is 3, 3 square, 9 minus 2 is 7, 7 square, -6 minus 3 is -9, so -9 whole square. We get 3 square is 9, 7 square is 49 and 9 square is 81. So what you are going to get? You are going to get this one is, so 129. Okay, so 120. So let's go to find the distance PR. Okay, let's find the distance PR. So the same formula of root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So using the coordinates of the point P and R, let's find the distance. So the coordinates of the point P and R become 4 minus of -2, 4 minus of -2 whole square, 9 minus 3 whole square, -6 minus 5 whole square. Let us solve this. So 4 plus 2 is 6, 6 square, 9 minus 3 is again 6, 6 square, -6 minus 5 is -11 whole square. So what you are going to get? You are going to get 36 plus 121. So let's change little bit question. We have to check whether the given points are collinear, right? We have to check. Okay. So observe the distances PQ, QR and PR. Clearly the PQ plus QR is not equals to PR. There are no matching of the distances of the addition of PQ plus QR and the PR. There are no matching. Therefore, the given vertices are not collinear. Therefore, P, Q and R are not collinear. Okay, let's solve one more problem. Verify that the points 0, 7, minus 10, 1, 6, 6 and 4, 9, minus 6 are the vertices of the isosceles triangle. Okay. So what are the isosceles triangle? The sum of the distance of these 2 points and these 2 points. PQ plus QR must be equals to the PR. Alright. So therefore, so let's find the distance between the given points. So let P be the 0, 7 and minus 10. Q be 1, 6, 6 and R be the 4, 9, minus 6. So let us find the distance between these points. So PQ is square root of x2 minus x1 whole square, 1 minus 0 whole square, 6 minus 7 whole square, 6 minus 7 whole square, plus 6 minus of minus 10 whole square. So that become 1 minus 0 is 1 square, 6 minus 7 is minus 1 minus square. So 6 plus 10 is 16 square. So you are going to get 1 plus 16 square. So there is a little bit of change in the question. The question is, we have to check that whether they are the vertices of the right angle triangle or not. Right? Okay, fine. So we have find the distance PQ, which is 3 root 2. We find the distance QR, which is 3 root 2 again, and we find the distance PR, which is 6 again. Therefore, using the condition of the right angle triangle, what is the right angle triangle condition? That PQR, that is PQ whole square, opposite square, plus base QR. QR is base square equals to hypotenuse PR square. So using the same formula we have checked that PQ square plus QR square equals to PR square, and PQ square is substituted, QR square is substituted, PR is already 6. So it is verified that P and Q and R are the vertices of the right angle triangle. So there are more columns in the textbooks. There are more 2 or 3 columns in the second exercise 12.2. So please take it as an homework. Okay. So we will study the section formula here. Let P x1 y1 z1 and Q x2 y2 z2. This point. Let point P x1 y1 and the Q x2 y2 z2 be the points. There is another point R, x comma y comma z. There is another point R we choose on the line PQ. Divide the PQ. We will divide this PQ, line PQ, in the ratio m is to n. There is some distance at the P to R and some distance at R to Q. So in the m is to n ratio, internally we will divide the line PQ. We will divide the line PQ internally. So the line PL, QM, RN are perpendicular to the XY plane. You can see PL, RN and QN, they drawn are perpendicular to the XY plane. They are at a 90 degree to the XY plane. As this is an XY plane, the line PL, RN and QM are perpendicular to the XY plane. Through the point R, draw ST parallel to the LM. So we have drawn the line ST parallel to the line M. It means these two lines are parallel. The line ST is parallel to LM. ST line is parallel to LM. The line ST will intersect the LP. This line ST will intersect this line LP externally. Intersect the line LP externally at the point S. You can see there is an extension. The line is LP, and from this point L there is an extension. And there is a point S. It means the external division of the line LP. The point S is the external point of division of the line LP. From the LP line, the line is extended to the point S, so that the point S divides it externally at the point S. Note that the quadrilateral, so there constructs the quadrilaterals LNRS. You can see LNRS. There is a quadrilateral like this. So this is S, R, N and L. So there is a quadrilateral. So this is a quadrilateral, and they construct another quadrilateral NMTR. You can see this one, NMTR. NMT and this R. So there exist two quadrilaterals. Okay, it constructs the two quadrilaterals. And you can see they are the parallelograms. You can see the quadrilaterals, these are nothing but the parallelograms. So using the concept of the ratio m by n, m by n is nothing but the m distance is the PR, this distance P to R, let this distance is P to R is m, and this distance be n. Let the distance PR is m and R to Q is n. Therefore m by n is PQ by QR. And you know that the distance SP and QT are same as PR and QR, because PR is parallel to SP, QR is parallel to QT. You can see PR, this PR is parallel to LN, PR is parallel to QR is parallel to LN. Similarly, the SP and QT, from this point SP and this QT, they are parallel lines, because it is just because of the external division of the line PL. As the external division of the line PL, the point is S, and the line SP and LM are parallel to each other. Therefore, PS, the distance PS and the line TQ, they both are parallel. You can observe in the figure that the line PS and the line TQ, they are parallel to each other. See here. So as SPR by QR is equals to SP by QT, it is just nothing but the difference of the distance SL minus PL. You can see SL minus PL. The total length SL minus the length PL will give the PS or SP. You can see here. The total length of the SL minus total length PL, SL distance by PL distance, SL distance minus PL distance will give rise to the PS distance. Similarly, QM distance minus TM distance, QM distance, QM distance minus TM distance will give rise to the TQ or QT distance. Similarly, these two proportions will be written here. So as these lines are perpendicular to the parallel to the z-axis, you can see z-axis, as the lines as PL, RN, QM, as the lines PL, RN, QM are perpendicular to the XY plane, as they are perpendicular to the XY plane, they are parallel to the z-axis. Remember, if the line is perpendicular to XY plane, it is no doubt parallel to the x-axis. It is no doubt parallel to the z-axis. So similarly, it is nothing but the parallel to the z-axis. It means there must be the difference of the z coordinates. It means this NP minus PL is Z minus Z1. This QM minus RN is Z2 minus Z1. So similarly, what we are going to get? We are going to get Z is equals to M into Z2 plus N into Z1 divided by M plus N. So this is the one of the coordinate of the external division of the point, external division of the line PL. Okay, so we can see here that the coordinate of the point R, the Z coordinate of the point R, which divides the joining PL into the ratio internally into the ratio M is to N is MZ2 plus NZ1 by M plus N. Similarly, by drawing the perpendiculars to XZ and YZ planes, as the lines PL, RN and QM, PL, RN and QM are drawn perpendicular to the XY plane. Similarly, by drawing the same lines perpendicular to the XZ planes and the YZ planes, what we are going to get? We are going to get Y equals to MY2 plus NY1 by M plus N, X equals to MX2 plus NX1 by M plus N. So Y and X coordinates we are going to get. It means the coordinates of the point R, which divides the joining of the point Px1, Y1, Z1 and the Qx2, Y2, Z2 internally in the ratio M is to N are nothing but Mx2 plus Nx1 by M plus N, comma My2 plus Ny1 by M plus N, comma Mz2 plus Mz1 by M plus N. So this is called as the section formula for the internal division. If the point R divides the given joining of the line PQ internally, if the point R divides the given line PQ internally in the ratio m is to n, then the coordinates of the point R are this. Okay. Similarly, you can see what is this formula? This is the section formula for internal division. That is, whenever the point R divides the joining of the PQ internally, we have this formula. The coordinates of the point R for internal division is this formula. Now, as soon as the point R divides the joining of the PQ in the external area, in the exterior portion, that is external division of the point of the line PQ, that is, if the point R divides the joining PQ externally in the ratio m is to n, between the Px1 by 1 z1 and Qx2 by 2 z2, then we have a section formula for external division. That is mx2 minus nx1 by m minus n, my2 minus ny1 by m minus n, and the last is mz2 minus mz1 by m minus n. So these two are the formula for the section formula for any point. These are the coordinates of the point R, which is nothing but which will be used for internal division of the given line PQ and this external division of the given line PQ. So all of you should note on this. This derivation will appear in annual examination every year. So this is very important for you. Okay. So we will solve some of the examples of the section formula for internal division as well as the external division. See here. Find the coordinates of the point which divides the line segment joining the points -2, 3, 5, 1, -4, 6. The given ratio is in the ratio 2:3 ratio internally and in the ratio 2:3 externally. Okay. So let's solve this problem. Solution. So first let's consider the given points. Let P -2, 3, 5 and Q 1, -4, 6 with the given points. First one, internal division. Internally, that is internal division of the given point. What is the ratio given? So m is to n equals to 2:3. It means m equals to 2 and n equals to 3 is given. So what is the formula for internal division? So section formula for internal division is mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, and similarly mz2 plus nz1 by m plus n. Okay. So x1, y1, z1, let us consider this as an x1, y1, z1, this as x2, y2, z2, m is given, n is given. Let us substitute here one by one. So mx2, m is 2, x2 is here mx2 plus nx1, x1 is -2 by m plus n. my2 plus ny1 by m plus n. Similarly, nz2 plus nz1 divided by m plus n. Try to solve this, we will get the answer. So 2 into 1 is 2, 2 minus 6 by 5, and here -8 plus 9 by 5, and here is 12 plus 15 by 5. Okay, you solve this. So 2 minus 6 is -4 by 5. 9 minus 8 is 1 by 5, and this is 12 plus 15 is 27 by 5. So this is nothing but coordinates of the given point which divides the joining of these two. That is, if P and Q are these 2 points, if P is this point and Q is this point, then there is another point R, which divides in the ratio 2:3, and the coordinates of this point and the coordinates of the point R, which divides the joining of PQ in 2:3 ratio internally is -4 by 5, 1 by 5 and 27 by 5. So what is second one given? The ratio is given 2:3, but the division is external division. Division is external division. So again, m is to n is given to be 2:3. That implies m is 2 and n is 3. And we have to use the section formula for external division. So what is the section formula for external division? M x2 minus n x1 by m plus n. M y2 minus n y1 by m minus n. M minus n. M z2 minus n z1 by m minus n. So let us use the x1 y1 z1 and x2 y2 z2 and m equals to 2, n equals to 3. Substitute in this formula. So this becomes m x2, m into x2 minus n into x1 by m minus n. So m y2 is minus 4 minus n is 3, y1 is 3 by m minus n. And the last one is 2 into 6 minus 3 into 5 divided by 2 minus 3. You can see I have substituted x1 y1 z1 here, x2 y2 z2 here, and you can substitute. You can take any point, take this as x1 y1 z1 or this x1 y1 z1, or you can choose this as x2 y2 z2, this as x2 y2 z2. That doesn't matter, you get the same answer. In general, I have taken first point as x1 y1 z1, second as x2 y2 z2. So solve this. So 2 into 1 is 2, that is 2 plus 6 by minus 1. Next, 2 into minus 4 is minus 8, minus 8 minus 9 by minus 1. And here 2 6 are 12, 12 minus 15 by minus 1. Solve this. So 2 plus 6 is 8, this is minus 8, by minus 1 is minus 8. Minus 8 minus 9 is minus 17, so minus by minus 17 is plus 17. 12 minus 15 is minus 2, minus of minus 2 is again plus 2. It means what we are going to get? We are going to get minus 8 and this is 17 and this is 2. This is 2 we are going to, that is 12 minus 15 is 3. 3 we are going to get. Okay students, one more example we will solve. Look at the question. Given that the point P 3 2 minus 4, Q 5 4 minus 6 and R is also given. R is also given. R 9 8 minus 10. All the three vertices are collinear. All the three vertices are collinear. Then we have to find the ratio in which the point Q, this point Q divides the PR. Divides the PR. Right? So we look at the solution. Okay. So let us see picture here. How this. So this is the point P, this is the point R. So there is a division of the PR by Q. The Q has already divided the given PR internally, right? So let's consider, in general, the condition is not given that whether it is a division is external or internal. In general, we will take it as internal division. So look at this picture. The Q divides the PR internally, and in some ratio. Let us consider some ratio. The ratio is some m to 1. Let the first distance be m. Let the second distance be 1. So by assuming that the ratio is m is to 1. Let us find the value of m. Let us find the value of m. You see here, as the 5, 4, minus 6, this is nothing but this point Q, which is already given as the point of division, the point of internal division. It means, so the coordinates of the point P are 3, 2 and minus 4. The coordinates of the Q are 9, 8, minus 10. The ratios are m is to 1. It means we have to use these information. We have to use these informations. Take this as x1, y1, z1. Take this as x2, y2, z2. Take this as m. Take this as n. Substitute in the internal division. So what is the formula for internal division? mx2 as the given formula mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, mz2 by mz2 plus nz1 by m plus n. So let us substitute the same value. So what this become? mx2, x2 is 9, mx2 plus n, x1 is 3 by m plus n, m plus 1. Next, my2, m is m only, y2 is 8 m y2 plus n y1 by m plus 1. Next one is m z2 plus n z1 by m plus 1. M plus 1. Okay, you see, keep the 5, 4 and minus 6 as it is. Simplify this become 9m plus 3 by m plus 1 and 8m plus 2 by m plus 1, and here is minus 10m minus 4 by m plus 1. So as these two ordered triplets are equal, use the definition of equality of the ordered pairs, equality of the ordered triplets. So using the equality of the ordered triplets, 5 is equal to the first term, 4 is equal to second term, minus 6 is equal to third term. You can choose any one. You can choose any one. You can equate any of these three coordinates, you get the same answer. Let us choose the first one. So let 5 equals to 9m plus 3 by m plus 1. Some students can go for 4 equals to 8m plus 2 by m plus 1, or some students can also go for minus 6 equals to minus 10m minus 4 by m plus 1. So the solution of all these three terms will be the same. So no need to solve all the three, let us solve the any one. So let us solve this one. So this becomes 5 into m plus 1 equals to 9m plus 3. Solve this. 5m plus 5 equals to 9m plus 3. Send this 5m plus 5 to right side. So 9m plus 3 minus 5m minus 5 equals to 0. So 9m minus 5m is 4m. 3 minus 5 is minus 2 equals to 0. 4m equals to 2. m equals to 1 by 2. m equals to 1 by 2. Okay, you get that? M equals to 1 by 2. It means 1 by 2 comma 1. So the given actual ratio is 1 by 2 comma 1. In this ratio, the point Q is dividing the joining of PR. In fact, PQ are the collinear already. They lies on the same line. In fact, PQ plus the distance PQ plus QR is already equals to the QR, or by some another means like QP plus QR equals to PR. In any of the form, the distances will match the definition of collinearity. It means by using the sectional formula for internal division and considering the ratio m is to n as m is to 1, taking these 2 points as x1, y1, z1, x2, y2, z2, the ratio m is to n become m is to 1. We have calculated, we get the m equals to 1 by 2. It means the ratio, the given value of the m is 1 by 2. And the solution is, we have to find the ratio. The ratio is 1 by 2 is to 1. In this ratio, that is m is to n equals to 1 by 2 is to 1. In this ratio, the point Q is dividing the PR. Okay, students, solve these problems. These are additional problems. These are already solved in the textbook. Using the section formula, show that the points given, there are 3 given points, they are collinear. Again, use the section formula to find the collinearity of the given points. Find the coordinates of the points which divides the line segment joining these 2 points, minus 1, minus 2, 3, 3, 4, minus 5 in the ratio 2 is to 3. There are 2 conditions given, one is internal and one is external. Okay, so solve the more and more problems on this. Okay, so in the textbook there are 3 more problems are given, 3 unsolved problems and 2 solved problems are given. Please solve all the problems and practice all these problems. So this is very important for the point of annual examination. Okay, so all the best.